Hi guys, let me just share my screen with you. Okay, so excuse my voice, I've lost it a little bit, but today we're going to talk about the depletion of ozone layer. So what it is, it's basically a layer that is 10 to 20 miles above us, and it basically filters harmful 90% of harmful UV radiation. And I'm sure as most of you probably enjoy the 10% for sun tanning, it actually causes a lot of harm. And the problems include cataracts, damages to crops, damages to immune system, and skin cancer. Um, Ozone depletion was mainly caused by CFCs, and ironically, CFCs were actually made for human safety because at that time, old refrigerators had harmful toxins such as propane and ammonia. So a scientist called Thomas Medgley in 1928, he synthesized a first commercially viable CFC, and to prove this, he inhaled CFC gases and blew it on a candle to prove that they were not flammable. However, nowadays this would be looked down upon, and basically you wouldn't get away with a proof like that. At that time, though, it was a remarkable invention, and they were known as the modern day refrigerators and air conditioners. Other things that include CFCs were hairsprays, and in the 1970s, they were really popular, and they all included CFCs. But they soon realized in 1978 that this caused ozone depletion. So in 1978, they actually banned CFC's usage in aerosol sprays by the US and many other countries. Um, However, it doesn't stop there. In the 1985, there was the discovery of the Antarctic ozone hole. As you can see in the graph, at 1985, there was a massive decrease in the ozone layer. Even though now we're going up a little, at that time it was a very alarming discovery because, it was only supposed to deplete 5 to 10%, but in less than a decade, a third of the ozone layer was depleted. Um, so to stop this, there was something called the Montreal Protocol, and what that is, it's basically an international treaty that is designed to protect the ozone layer by phasing out any substances that have CFCs or any other harmful substances that can cause ozone depletion. And this has actually delayed global warming by more than a decade. And if we continue to do stuff like this, by the 2030s, you might see a reduce in millions of skin cancer patients per year. So now that you guys know a little bit about ozone depletion and what people have done to stop it, let's look at what we do to stop it. And there are a few bullet points here, such as limiting private vehicle driving, which I know can be hard, but you can do other things such as use eco-friendly household cleaning supplies, avoid cutting down trees, or plug off electrical devices when they're not in use. I live in the UK, so there's switches in our outlets, but I know in America there isn't. So maybe you guys can purchase external wires that have switches on them to stop this. And lastly, I would like to finish off by a quote, and that is that a damage to the ozone layer is a damage to human safety. So please take your precautions, and thank you for listening.
Hey, are CFCs is that also like in hairspray, or is that something else I'm thinking of? Like, you know what I'm talking about?
They're in refrigerators. Some of them still have them, but most of them are gone.
Oh, okay.
Is there any more questions? No.
Um,
sorry, Hudson, you can go ahead.
I want to ask, how effective do you think the individual responsibility approach for greenhouse emissions and stuff is?
To be honest, I don't think it's that effective just because there are also nuclear like stations and like factories and stuff that actually have the major part in ozone depletion. But we can try our best to do whatever we can.
I completely agree with you because I was like doing reading on it, and apparently a big part of why like there's the whole concept of the carbon footprint and like the individual household being responsible for carbon emissions is like companies spreading propaganda that like you can have a reasonable impact on greenhouse gas emissions when like
Yeah.
private households really don't have that much of an impact. Like
Yeah.
even a lot of farms that have like millions of animals on them have a much less significant impact than any factory you can think of or any major corporation.
Yeah, that's true. Is that all the questions?
Hey, Zaafira, I think the ozone issue, I think it's really interesting because I remember learning about it in class forever ago, my freshman year of college. I remember learning that the ozone layer is kind of like healing. And I think it's interesting because I recently read an article that like the sale of CFCs, like you mentioned, how like Americans were so quick, like kind of across the board to like start banning the sale, like get educated about it. And I guess like how do you think like we can get Americans or like just average citizens interested the same way they were about CFCs, about like stopping the sale and like really like fixing the ozone layer, like with other like environmental or climate issues?
I think, sorry, my voice is really bad. I think signing petitions could help because I think it does have a major impact and some things do get stopped by signing petitions. So, yeah. Is that
Like,
all?
going off what Mara said, kind of like even with signing petitions and stuff, like I feel like the countries that are causing like the most damage to the ozone layers don't really care about that's it. Like don't really care. Like the corporations that are doing it, like if they if America is like, okay, yeah, we need to have these regulations and like British, like the UK and stuff, like places that are first world countries, they just move their factories overseas to like countries that don't have those regulations. So I feel like it has to be a global thing or it's not going to stop because like big companies don't really care where they do their dirty work. They just need a place to do it. And it's honestly just hurting third world countries more than like we don't see the air pollution and like bad like like horrible seawater, like like I mean we still do, but like it's obviously more regulations than there were before, but like now it's like third world countries that are getting affected by it more and more.
Yeah, I think they've done their damage and now people are getting more aware after the damage has been done.
Yeah,
Yeah, I
Ruby,
think
that's a really good point because I know everyone, at least for me, in almost every bio class I've been in, I've almost always had like white professors, and they've always harped on the fact that developing countries, third world countries, they use da amount of resources, like they have such a big carbon footprint. And I think it's really funny that these same people don't harp on like the way America's used like natural resources the same way, or how like the West contributes like in the same manner. Like in my experience, it's always been harping on how developing countries are using all these resources, like contributing to like climate change and stuff like that. But you never really see it emphasized like about how the Western world has historically done that for so much longer.
Yeah.
And I think that's where something like the Paris Climate Agreement like can go a long way. Like if you have all these countries coming together and stuff like that, and like actually making plans and like following through with those plans, like Hassan said, like it's mainly these companies that are doing it. So having governments like unite and hold each other accountable, like that could go a long way. But like that's another issue, right? Like Trump pulled America out of the Paris Climate Agreement. So it's like, okay, now what? And same thing like with what Myra was talking about. Like I kind of learned the same thing, but like if you look at it, like for the past 200 years, right, the United States, the UK, like all these like Western nations, they've been doing most of the polluting. And now that they're like industrialized and like all set up, they're like, oh shoot, like we're not really polluting like that. But it's like, okay, these other countries, they need the opportunity to develop the way that the United States and other countries have been doing for the past 200 years now. And we kind of have to pick up the slack.
Yeah.
That's kind
To
of
sort of build off of yours and Myra's point, there's also like people will blame third world countries for going through the industrial like cycle that America and the UK went through. But then there's also such a like resistance to providing them with green technology, instead of like it's like, oh, you have to let them naturally grow, but them using biofuels is wrong, them burning trash is wrong. And it's like, well, the UK and Europe, like these were the energy sources used before industrialization, and then it went to coal and fossil fuels. And even now, like these first world quote unquote industrialized countries haven't really moved to green power systems, but we have the technology to do so. And we just deny a lot of countries that could also feasibly move to green power systems the technology to do so, out of like fear mongering claims of like, oh, it's nationalism, you don't want to spread our intelligence, you don't want to spread our technology or resources, because then you're a socialist, you're a globalist, you aren't a patriot, you aren't an American. When like realistically it is, I mean, whatever country you're from, whatever your nationality is, if the earth is gone, your country doesn't exist and your nationalism is gone, right? We're all spacist at that point because there's nowhere left.
How effective do you guys think petitions are? Like, don't they? I honestly don't know much about it. I tried to Google it a few weeks ago, and all I got back, like the only result I got back was that after a certain amount of signatures, officials are only just required to look at the petition. Like, do you think real change can come out of signing petitions?
I think protests kind of help more because like petitions aren't really like put on the news or like shown, you know, like you don't get as much like media coverage. But I feel like if you have the public, like the large majority of public by your side, maybe you can like make more change. That's why protests are a bit more effective.
I think as long as we have the current state of democracy that we're in right now, petitions won't be as effective as, you know, we want them to be. We have old heads in office talking about shit that they won't be here for, in layman's terms. So yeah, I don't think they're as effective as we can make them. You know?
Wait, we're not actually living in a democracy. No one can tell me different.
Yeah, we just gotta.
If you actually talk to your professors who are actually woke, we're not living in a democracy. The more you think about it, just think about it, y'all. Just think about it.
I mean, like, okay,
Yeah.
so for me, like, when it comes to petitions and stuff like that, like, I'll sign them, but, like, you know, it comes to a certain point where it's like, okay, like, I'm signing these petitions, but then, like, nothing's changing. So then, like, I'm not gonna lie, like, I guess, like, sometimes it feels like a hopeless cause when you're signing all these petitions and it doesn't get you anywhere.
I think part of the problem with that might just be the medium used. Like a lot of people will post on social media, which is powerful. Social media is an amazing tool, right? But you need like huge coverage on social media or public media to get recognized. But most people don't know this. If you email your local senator and you like put certain like things in the like subject bar of the email, the senator is forced to read that email. So like a strategy that has been used in states to like one famous one was removing the presence of like police cameras in public areas in Chicago, or reducing the presence, was literally just sending like hundreds of thousands of emails to their local senator, to the point that like even like lobbied issues were getting swamped out by the public just repeatedly emailing this person, until like the issue had to be addressed by the media and the public news, because the Senate was bogged down, like the local city council and Senate was so bogged down in these emails that they had no other topics on like the docket to discuss. And people would actually show up to local city hall and like Senate meetings, and they'd be like, yeah, this is the only topic we're here to speak for, and we'll all like give our time to this one individual who's going to get up and now speak for like 5 hours on this topic until city hall does something about it. So I think that's an effective way to petition. I just don't think it's one that's very common. I think more people will sign a petition, and then like when an actual actionable change comes around, something that you can act on, a lot of people don't, at least in my experience, don't do the actionable part of the petition. They just sign it and then say, yeah, supporting Black Lives Matter, supporting this cause, that cause, etc.
Yeah, Hassan, those are all valid points. I definitely agree with you. Zaafira, I totally screwed up your name. I'm sorry, Zaafira. Thank you so much for such a good presentation. We had really good discussion on it. But now I think we're going to segue into our next presenter. So we have Humza and Erik, and whoever wants to go next, feel free to start sharing your screen.
Okay, so I'm just gonna go next. Is that cool?
Yeah, that's fine.
All right, cool. All right. So I started sharing screen. Can you guys see it?
So
Host disabled attendee screen sharing. Okay, Cool.
I'm sorry. Wait, let me try to fix that. Okay, I think it should work now.
Okay, cool. Oh, that's nice. All right. How do we do this? How do you get it to
There you
okay,
go.
you
We
guys
can
see
see
my
it now.
screen?
Yeah, we can see it.
All
Yeah,
right,
we can
cool,
see it
cool.
now.
How do you all right, present?
Now it's gone.
All right, cool. So how's everyone doing? My name is Humza Abdeen. I'm
We
currently
can't see your
Hello.
Wait,
presentation.
Hamza,
Can't
it's
see it anymore.
gone.
You can see it.
dang, I look crazy, don't I?
You
I
do.
look real crazy. All right, now can you guys see it?
Yeah,
There?
you might want to make it full screen. Yeah, and there you
Yeah,
go.
there you go.
Now we can
Okay,
see
so
it.
it's there.
Yeah.
Okay, cool. Dang, I was so confident too. All right, so my name is Humza Abdeen. I'm currently a junior at the illustrious North Carolina Central University. I just want to take this opportunity to thank everyone for allowing me to be here. Today I will be talking about Project MK Ultra. So this is one of those projects that I'm gonna sound like a total nut job, like conspiracy theorist, like it's all a government cover up. So I'm not gonna jump directly into it. First, we're gonna be talking about ethics. Nice, ethics and morals. I feel like these are things that are very important when it comes to this presentation project. So morals is described as a lesson, especially one concerning what is right or prudent that can be derived from a story, a piece of information, or an experience. And then ethics is a moral principle that governs a person's behavior or the, I forgot how to read, of an activity. So before we actually start, I'm gonna put you guys in an ethical dilemma. So Stephanie was supposed to tell a certain guy friend, wow. I'm gonna start over. So Stephanie was supposed to tell a certain guy that her good friend had a crush on him. Instead, Stephanie ended up hooking up with the guy herself, and to make matters worse, she lied about it to her friend. Now that things are spinning out of control, what is she supposed to do? So let's just get some responses. Myra, what would you do in that situation?
I think if I was Stephanie, I would just be honest. I'd be like,
Okay.
I'm sorry, friend. Like, he was cute. Like, I did that. I would just be honest. I feel like lying at that point would just make everything worse. Because there's
Okay.
no way that if her friend has a crush on this guy, he's gonna find out.
Definitely, he will find out. Okay. Let's get Hassan. Is that how you pronounce your name? Hassan?
Hassan, whatever.
Okay, what would you do? What would you do?
I mean, me personally, I think it would be ethical to not do this in the first place, but yeah, also own up to it. But there's also a lot of like schools of like morals and ethics, right? Like if you were Kantian, or if you look at it from a Kantian point of view,
Yes.
you shouldn't ever tell her friend, because like causing any harm is morally wrong. So it's better to keep it a secret and then force the guy to keep it a secret without in any way harming both of you or the friend, which is,
Very true.
I mean,
Very true.
practically impossible, but there are different schools of thought on it.
Yeah, definitely. I just want to do a brief overview on it. I don't want to go in depth on the different schools of thought. But let's get some more responses. What would you guys do?
Hamza, I can't believe you put this in your PowerPoint.
Well, you gotta wait. There's a lot more.
Wait, I honestly, personally would tell my friend, because I feel like if they found out from someone else, it would hurt worse.
Yes. Me personally, I'm a big believer that you can only control your own actions and own thoughts. So, if I slept with my friend's girl and he had things for her, I'd be like, listen, man, I don't know what you want me to do. Like, it's her choice. If she wants me, then it is what it is. But if she wants you, bro, just do you, keep it pushing. So the next dilemma I'm gonna put you guys in is a moral dilemma. So you're a doctor at a top hospital. You have 6 gravely ill patients, 5 whom need urgent. Damn, I really cannot read. For an urgent need of an organ transplant, you can't help them though because there's no available organs that can be used to save their lives. The 6th patient, however, will die without particular medicine. If he or she dies, you will be able to save 5 other patients using the organs of the 6th patient who is an organ donor. So what do you do? Come on, guys. What do you do?
This is really hard.
Zainab, you're like echoing.
This is really hard, but I think the best thing to do.
Zainab's mom just
Zainab, do you want to try and type it in the chat if you can't solve the echo?
Guys, can you hear me?
Yeah.
She
I'm
can
over
talk
here.
at mine.
Okay.
So it's hard, but I think I would just give the one patient the medicine. Like that's really, really hard. But the first thing you're taught, I guess, as a doctor is to do no harm. So I would just give the patient the medicine and hope for the best for the other 6.
Wait, honestly, I kind of agree with Zainab. Like, obviously, as a doctor, you can't be like, oh my God, like, you can't withhold a treatment from that patient, right? Like, I think that would be unethical to withhold the patient from the sixth, or withhold the medicine from the 6th patient. I think if the medicine does come, you should give it to that patient. But if you're unable to find that particular medicine, and if like something does happen to the patient and they do pass away and they are an organ donor, then I can see how it would be ethical to then take that patient's organs and then donate it to the other patients who need it. But in my opinion, I think that withholding treatment from any patient would be unethical.
Okay.
Yeah, I agree. If you're a doctor, you have to like, you have to do what's best for your patient at the time. That like, so if you're dealing with patient 6, you have to give them the medicine if you have the medicine. But if they do die on your watch, or if you should at least like tell them like if they're not an organ donor already, like talk to them and be like, yeah, there's like other patients, like would you consider being an organ donor? Maybe just ask them that, and then try to like get them to be like, yeah, like I'll be an organ donor, like if I do die. But just like, but if you have the medicine, you should give it to them.
Humza, what would you do?
Interesting. I think I would say the 5 other patients, let that one die. I think it falls into those, for the greater good. I think I'd rather see 5 living patients and have one die than, put all my time and resources in one patient. I don't know. It's interesting. It's like there's no right or wrong answer. Very subjective. But wow, that's interesting. Okay, cool. So now we will be talking about LSD. You guys might be like, why are you talking about LSD? That's kind of random. It all makes sense in the end. So I think the first question I want to ask you guys is, why are drugs bad? Why do we call them bad?
Yeah, I can go first on this, but I think that drugs are bad because obviously they put you in the wrong frame of mind. You don't know what you're doing in that moment, and then whatever you do in that state of intoxication, it could have severe consequences on someone else. And in addition to that, it's also wrecking your own health. Yeah, I mean, I'm sure we know cocaine, meth, all the hard drugs, why they're bad for you because they literally destroy your body.
Yes, very true.
Wait, I think I think other than just destroying your own body and stuff, doing drugs or drinking or whatever, the addiction part of it doesn't just affect you, it affects everyone around you. So it's even if you do these drugs just for fun, once you get addicted, it can be a really bad cycle, not only for you, but your family members, your kids, your extended family, and even society as a whole. It's just so it's really just affects everyone around you. It's not just one person that's affected by it.
Mm-hmm. That's very good. All very valid points. So the reason I actually asked is there was this one brief period in time. I think this goes on today, but when it comes to drug usage and drugs, people have to do research on it and understand why. So I'm just going to do a brief history on LSD. So it was actually discovered by a Swiss scientist by the name of Albert Hofmann in 1930. It was really interesting. He was in his lab. He was just messing around with different chemicals and stuff. And he was like, wow, this shit hits. This right here goes pretty hard. So, and just the reason I'm talking about LSD is because it was used so much in this project that we're going to be talking about, Project MK Ultra. So LSD is found to be naturally occurring in multiple sources, like ergot on fungus that naturally grows on rye and other grains. And in the 60s, it was actually used in the Cultural Revolution. So you had a bunch of hippies just dropping acid every now and then. And it was it started becoming more recreational once it gained the reputation of being consumed in a pill form. And naturally, forms of LSD have been used in multiple civilizations for centuries, and they've been used in spiritual experiences and just recreationally. So I thought this was funny. I actually laughed for a good amount of time, but it had been found that there was ergot on rye in Salem. So during the Salem witch trial, people were just tripping. They were just high all the time, just you're a witch, cursed witch. I thought that was hilarious. In my mind, I'm just imagining people running around the city just on acid. I don't know. I thought it was funny. And so what happens when you take LSD? So based on your dosage, you can have visual effects, change in relations such as touch, mood changes, impacts on thinking. And so these are the actual effects on LSD. So it has been noted that your frontal lobe is very important when it comes to psychoanalysis, for the reason that this is where your ego is, because it's important for thinking, planning, organization, problem solving, emotional, behavior control, and personality. And so this is just quick little thing of your brain. And then this is actually what happens when your brain is on drugs. You guys know that like Dare commercial? It's like, this is your brain. This is your brain on drugs. This is kind of what's going on over here. So as you can see, there's a lot more activity in the occipital lobe. You have more of it in your frontal lobe, so that impacts your thinking. These are patients that are on a placebo. And so what's even more important is that people that are on LSD, they actually go through this thing called ego dissolution or ego death. So just a quick overview. Your ego is important. It's your one self of sense. You have the id, which is the innate sense of desire, and then your superego, which is the part of the mind that is important for self-criticism and conscious. So your ego is very important in this sense, as I said in the last slide. So you go through ego, which is the complete loss of subjective self-identity. So you're really just sitting there, like head empty, no thoughts. Like there is no you. You're just there. You know what I mean? Isn't that crazy? All right, cool. So this is just some LSD natural sources. So I can't pronounce half of these. I'm not even gonna try. So yeah, if you wanna scavenge some mushrooms, this is what they look like.
I had a question about the ergo on rye. You mentioned that everyone in the Salem witch trials was stripping, unless they were just.
I'm sorry.
Unless they were just consuming like the wheat without cooking it into an actual baked bread. Wouldn't the LSD denature in like the heat and the light? Because it's a drug, and it probably has a denaturation point, and bread is baked at a pretty high temperature for a significant period of time, especially during a few centuries ago when it wasn't like baked in ovens that were set to a perfect temperature. It was just superheated, and then you wait an hour or two for it to rise.
Yes. Don't know the answer to that one personally. I can do more research and definitely get back to you. But that was good. Good. So any comments, questions, or concerns? Okay, cool. So now we're going to be talking about Project MK Ultra. And so the background on this is that, just quick background. So World War II ended September 2nd, 1945. The Cold War started 1947, and it kind of lasted until 1991. The Korean War was between June 25th and June 27th, 1953. And so the Red Scare, which is a widespread fear of the rise of communism and spies found in the US. And then, you have like the Rosenbergs, Anthony Walker. And so the main concern that the US government had at this point was when soldiers came back from these wars, they began to express sympathy for their communist enemies. And so this seriously led the US to believe that they were being brainwashed by the USSR or the Chinese forces. This is like a legitimate fear that the US government has. And so what they began to do is they began to do projects like Project MK Ultra. And the goal of this project was to brainwash people so that they could basically tell them what they wanted to believe. So the project was funded by the CIA and the Canadian government under the name of the Society for Investigation of Human Ecology. And it was a covert operation to do research on brainwashing and develop techniques that could be used against Soviet spies. And so between the years of 1953 and 1973, the CIA spent $62,000. So that was back in their money. I didn't convert it, but it's a lot more money now. And so who led the project and where? So the CIA funded a Canadian psychiatrist by the name of Dr. Cameron, who co-founded the World Psychiatric Association. And so the basis of the research was psychic driving and deep patterning. And so the project was led at the Allen Memorial Hospital, but there were over 80 institutions, universities, hospitals, prison, and pharmaceutical companies that were all in charge and began to do research all over the country. So the project, the actual basis of the project was they were all given drugs and electrical shock to the brain while audio was playing for hours to erase their memory. So people would literally be like in drug-induced comas, just with audio on repeat, electroshock therapy multiple times. And it was all experimental. So like people were just like, hey, I think this is gonna work today, just whatever. And so patients were exposed to large doses of electroshock therapy, kept asleep for months at a time with tape being played while the patients were asleep, LSD, heroin, morphine, tamazine, also referred to as and all these other drugs were being used. And so the poison expert Sidney Godwin believed that the agency could harness the drug mind-altering properties for brainwashing or psychological torture. So what is psychic driving and depatterning? So psychic driving is where patients are subjected to continuous repeated audio message on a loop to alter the behavior, and depatterning is brainwashing to remove normal patterns of thinking and behavior. So what they believed is if you could drug up people, right, and you could get them in this phase where they're like ego death, ego dissolution, all their brain activities going on. And if you were to play repetitive audio on it, you could make that person believe what's on the tape. So that was the whole basis of this thinking. And so files on the project. So like I said, there were all these institutions and the records were kept so poor because it was a covert operation. The patients weren't really recorded or tracked. So, now you can get information on it due to the Information Freedom Act of 1967. Any person has the right to access federal agency records or information, but the files are now archived online. Some information is hidden, so they are still declassified or classified, I'm sorry. And so the records are just all over the place. So yeah. And then after the project, the federal government was like, oops, LOL, my bad. So they compensated the victims. They turned away 250 applicants because they weren't tortured enough or they hadn't gone through enough trauma to receive compensation. And there were countless amount of people who were not informed about the compensation at all. And so I guess my question to you guys was is there a need to do mind control research? Was that something that we should have prioritized back in that time? Cool. Okay.
I don't think we should have prioritized that. But actually, I have a quick question. I may have missed this when you were presenting. But how do they choose the patients to perform those studies on? Like, was it like volunteers who were compensated for it? Like, how did they recruit who was the study? Like,
so the recruitment process, from what I understood, was kind of tricky in the sense that sometimes patients were selected that were already at the hospital that had some psychological disorders. Sometimes they would post ads and flyers like, hey, we need, X amount of patients for this project. And they wouldn't like really tell people what's going on. And then once they had them and they signed that release form, then yeah.
No, that's really awful. They're literally preying on like vulnerable in our population, like literally mentally ill people who need that help. No, yeah. I don't think there was any need for that mind control research. And honestly, in the 1900s, like even everything Hitler was doing, like experimenting on people he deemed inferior, like in concentration camps, and we got all this scientific like knowledge from it. I don't think any of that research was necessary at its core. Like even though we got all of that knowledge out of it, like at the end of the day, he hurt so many people like in immeasurable ways. Like
so that's actually what's really interesting. The whole ideology of eugenics actually didn't start in Nazi Germany, but it started in the United States during the time of slavery. I'm actually in this course right now, and I've talked about it in a few of my courses, such as Black Psychology, the Black Experience, and one more course called Social Problems. So what's really interesting is that, everybody's like, the Nazis did X, Y, Z, but it was the United States during the time of slavery. We did some pretty pretty messed up stuff. That's kind of why we see that institutionalized. Like you still see today where people are like, Black women don't feel pain as equal to other women. Like that's like actual doctors to this day still believe that, which is mind boggling. So yeah, definitely right.
Can you repeat when like this project was, like what time period?
So it was between the time period is kind of tricky too, because different documents and different files will say things. I know there's a Netflix documentary on it right now, but the dates that I could find were between the 50s and 70s.
So do you think like, like I took a class and we read like One Who Flew Over the Cuckoo's Nest or something like that, and it talked about like mental hospitals and the experiments they did in the 1960s. Do you think like was this like the same thing? You know what I'm saying? Like was this part of it?
From my understanding, when it used to come to like asylums and stuff like that, the whole objective wasn't to rehabilitate the patient, but it was kind of to push them away from society. So, you know,
Yeah.
you have people that suffer with autism and other psychological disorders. At that time, our society wasn't to help rehabilitate these people, but it was more or less like, how do we get rid of them and push them in an institution where we don't have to see them, you know?
Exactly. Yeah.
But I think the reason why asylums are created and the reasons why people got away with so much crazy stuff was because, like, who's regulating them? You know what I mean? It's like once they're there, I don't see them, you don't see them.
Mm-hmm.
It doesn't bother me anymore, you know?
Yeah.
So yeah.
Interesting.
So that's a really interesting point. Like it, like the fact, like the last sentence you said, like it doesn't affect us, like we don't see it, etc. Like I don't know if you guys have heard like that whistleblower and like the ICE nurse, how they're doing like hysterectomies and
Mhm.
like literally removing whole ass organs from undocumented immigrants. Honestly,
Yeah.
Hamza, everything that you said when we were talking about this is so on point because there's so much that we brush under the rug when it comes to like science and all these people like literally experimenting on society's most vulnerable. Like we talk about MK Ultra as if it's in the past, but that shit is still happening today.
Yeah.
Like just not reported on. And honestly, all these news companies are owned by the top 1%. They don't want to report on something that's going to offend their sponsors. I actually read an article on that. I can link that on the blog as well for you guys to read. But it's really important. And this stuff is happening around us all the time.
We actually, in my sociology of medicine class, had to read an article, I think last week, about undocumented immigrants working in strawberry farms in California. And basically, like, they have a whole, like, social hierarchy inside the farms because, like, it's, like, the documented Mexicans and then, well, it's the whites and the Asians at the top. And then it's, like, the documented Mexicans. And then it's, like, the documented Mexicans who don't speak that much English. And then it's, like, the undocumented Mexicans who can still understand English. And then at the very bottom, it's, like, undocumented Mexicans who don't speak English. So like they're obviously like they're like basically slave workers in strawberry farms and stuff. And it's just like one thing that really stood out to me from that article was basically like they said they were like these like farms are hidden between like the hills because it's like literally like they're behind like the backyards of like the 1%. Like people who live in the hills in California, they are the 1%. And like the strawberry farms are like right behind them, like they're tucked in between the valleys and stuff. And I thought that the article is really interesting. Like I'll link it in like our next email and stuff, but it just shows that like and it basically followed two men who tried to get like help, and one of the guys basically like his legs started hurting and stuff, and he was like, can I go to the doctor? And they were like, no. And then eventually like he could barely walk, and they're like, okay, fine, we can take you to the doctor and stuff. And the doctor was literally like, oh, it's because you're not picking the berries right, that's why you can't move anymore. And he was just like, are you serious? Like, no, he's overworked obviously. And then as soon as like the season ended of like strawberry picking, they were like, oh yeah, you feel better now, it's fine, because like he didn't have like insurance anymore, like he couldn't pay to get healthcare. And like he could also like they don't have any money too because they have to pay the border patrol off to not send them back. And they like basically the people don't give them that much money, and they send money back home to their families in Mexico who don't like obviously are not that rich to start off with. That's why they're crossing the border illegally, risking their lives to work like jobs that they get paid like $2 an hour for. Like it's actually so like disgusting. And the fact that like I didn't even know about that until I had to read it, and I'm 19 years old, and like stuff like that happens in North Carolina too. Like it's not just in California. Like California seems so far away, but it is still part of America. Like stuff like that happens in North Carolina. There's so many really rural areas in North Carolina. Like you cannot tell me that stuff does not happen here. And like there's also a lot of like a big Native American population, and they're so underserved and like overlooked. It's terrible. So like I think like the fact that we go through so many years of schooling and we just don't learn about so many minorities that literally live all around us, and our privilege just overlooks everything. Like even as an immigrant, obviously we face issues too. Like the immigrants here, especially Asian immigrants, were like the newest immigration, you know, in America. But like we have so many more like rights than like people who came here like illegally. It's not illegal, but whatever. And like like Mexican immigrants, African American slaves, and like the native population, they went through so much just so we have like we can start at the base rights that we do start at, which is like literally horrible. So I don't know. It's just like this seems so far like far off and like so like this is so long ago, but like it's really not. Like the amount of like mistreatment that happens is like disgusting, and like the Native American like reservations and stuff are treated so horribly in America. Like they always have like really bad. Oh yeah, and the other guy had alcohol issues. Like he was like an alcoholic and he was abusive and stuff, and he literally tried to tell the people, he was like, I'm alcoholic, like I really want help, like I want to get better for my family and stuff. And they're like, we can't do anything about him, he's a drunk, because like the guy that was there spoke like their native language and English, so he was like helping translate, and he was just like he was like, what? Like the guy was literally asking for help, and they were like, well, he's like abusive and a drunk, so we can't help him. And that just like perpetuates stereotypes about Mexicans, and like even doctors like perpetuate the stereotype by Mexicans by not treating them properly. Like if you're not going to get them help, they're obviously they can't, like, you know, you have to help them. Like you can't just be like, oh, they are the way they are, like we can't do anything about it. So I think that's just like interesting that, you know, it seems like it's so far off, but it happens like every day. Wait.
Yes. Yes. Yeah, all very valid points. Yeah, I think this is some government cover-ups, some more government cover-ups that occurred. I think pedophilia in the Catholic Church is one that we overlook a lot. And this is some further reading if anybody else is interested. And yeah, that's it for me, guys. Appreciate it. All right, cool.
Humza, thank you. I think we'll move on to Erik now because I want to make sure he has enough time to present as well.
Yeah, really good job. It was a really interesting presentation.
I'm not gonna lie. So I did mine on genetics and like self-development, and I don't think I'm gonna finish at 5. Like, there's no way.
Well, we can go over 5, or would you like to present in October, like October 3rd? What would you prefer? You could present first, like in our next meeting, or you could present right now if you want.
Yeah, Erik, I'm fine if it goes past 5. Like, I don't mind. Does anybody else mind? Y'all can speak now and we can decide now.
No,
I'm cool with it. That's fine.
Oh, is everyone fine with it?
Yeah, that's cool.
Okay.
Yeah. If you're not fine with it, just text in the chat or just let us know.
Oh no, I'm good with it.
Okay, then you can go ahead. You can share your screen. I think you should be able to.
Okay, cool. Yeah, mine may go like quite a bit over. I wasn't expecting there to be 3 presenters today, so but anyways, wait. Can you see? Is it showing?
Yeah, we can see it.
All right. Wait, sorry. I cannot see. There we go. All right. Wait, can you see it, all of it? Or is this in the way?
No, you're in presentation mode. I can see you. We can
Okay,
see
cool.
your screen, yeah.
Hello, so my name's Erik Fain, and well, just to give a little background about myself, I'm in the biology department at NC State in the integrated physiology neurology program. So I'm really interested, obviously, in like physiology, and I'm currently taking an immunology class, and we talked a lot about genetics and about different immune cells, and this is specifically about immune cells. So I'm going to be doing my presentation on VDJ recombination and the RAGS protein. Oh, wait, how do I? Okay, whatever. So the name of the article is called Single Molecule Analysis RAG-Mediated VDJ DNA Cleavage. And I highlighted David Baltimore because he's the one who, like, I think he led this project along with other research papers. And he got a Nobel Prize in physiology and medicine, I think in 1975. And this is one of his research articles that got him that prize. So just an overview about what VDJ recombination and cleavage, I'm gonna have to give you a lot of terminology and background because this mechanism is very I don't know if anyone has Dr. Psych, but he calls it very convoluted. and it's really complex, and we don't know every specific detail, but we know a lot about it. And his research was like the leading research in like discovering this mechanism. So just a background about what VDJ recombination is and stuff. So this deals with B and T cells in the immune system, and they are part of the adapted immune system. So B cells, they function as antibody secreting cells, and T cells, they are for attacking cells that are in um, that that are infected by viruses. So as you can imagine, they have to have cell receptors on them in order to identify like which cells are bad and which cells aren't. So BCR stands for B cell receptor, and TCR stands for T cell receptors. And antigens are like molecules on the foreign cells that the B cells and T cells recognize. VDJ are gene segments inside the B cells and T cells that code for the BCRs and TCRs. And just to further elaborate like terminology, RSS means recombination signal sequence, and these are adjacent and on the DNA helix, I guess, and these are right beside the VDJ gene segments, which, like I said previously, because I really need to hone in this point, these genes create pretty much, they code and create the cell receptors on these cells. And the RAG protein is what does the whole mechanism. So it's a protein outside the DNA or the nucleus. It diffuses in, and that's what it recognizes the RSS, which is the signal sequence, and it attaches to it. And I'm going to explain in a lot more detail soon, but I just want to introduce those vocabulary and terminology because pretty much you need to know that in order to understand the study. And this is a prime example of the central dogma of biology. And I was wondering I'm hoping, does anyone know what the central dogma of biology is, and maybe how you can apply it to this situation?
DNA, RNA to fucking protein. I've learned that so many times now.
Exactly. So the DNA in this instance is the VDJ gene segments on the DNA helical loop or whatever twist, and along with the RSSs. And then the protein is the cell receptors for BCRs and TCRs. Okay, cool. So they were pretty much trying to figure out what the mechanism of RAGs and how it impacted B and T cell development. Okay, so before I get into their experiment, I'm gonna explain the mechanism that they were trying to prove, because it's really confusing, like I said before, and complex. And if I just tell you the experiment, you kind of won't understand what it's like. You won't understand it. So here's just the picture they gave me in the research article, but I have a better picture that actually Dr. Michael Sykes, he gave in his PowerPoints, and I think this explains it so much better. So to give you context, this is in the nucleus of B cells and T cells. And these gene segments, B, D, and J, those are the gene segments. And the ones that say 2312 are the RSSs, the signal sequences right beside the B, D, and J segments. And the reason why this is so important is because this is where the RAGs protein, which is this green blob, they only bind to specifically the 23 and 12 RSSs. And specifically, these V's and these J segments are, the V segments only have 23 RSSs, and the J segments only have 12 RSSs, which is very important because they were trying to figure out the significance of RSSs as well. So as you can see, and just to like give you even more background, on the helical, on the DNA, there's lots of V segments upstream. So there's V's, V1, V2, there's even more than that. And they all have 23 RSSs right beside it. And then there's a ton of J's on the other one. And I'm not really going to go into much more detail about that, but that's just the idea of it. So pretty much when RAGs come in, they found out that RAG1 and RAG2, they connect the 23 and 12 RSSs, and they cleave the DNA in between it. So all this DNA, can you guys see my mouse? Sorry, I'm trying to point with my mouse.
Yeah, we can see it.
Okay, cool. And please tell me if you don't understand. I also have a video to hopefully clear it up. But yeah, it cleaves it. It makes this signal joint with a bunch of just random DNA in between it, and this it puts the V and the J right beside each other. So what that means is that when it's coding or making protein from the DNA, this is a new this sequence codes for the antigen receptors. And I'll go into more the significance later on. So here's a video. Oh, let me get that real quick. Sorry.
Immunoglobulin genes are composed of separated segments of DNA that become joined together by a process
Wait, can you guys hear that?
Yeah, we can hear it and we can see it fine.
Okay.
called somatic recombination to make a functional gene. In heavy chain genes, there are 3 gene segments: the variable or V segment, a diversity or D gene segment, and the joining or J segment. Light chain genes, such as those shown here, have only 2 gene segments, the V and the J segments. Gene segments that can be recombined have specific sequence motifs adjacent to them, called recombination signal sequence, or RSS motifs. A protein complex containing the products of the recombination activator genes, RAG1 and RAG2, binds specifically to the RSS motifs. In this example, flanking a V gene segment and a J gene segment. The individual gene segments, to whose flanking RSS motifs the RAG protein complexes bind, are selected at random from a number of copies present at each gene locus. The RAG protein complexes bring together the gene segments to be recombined and cleave the DNA exactly at the junction of the gene segment and its adjoining RSS motif. The cleavage creates a hairpin of DNA at the end of the gene segments and double-stranded breaks at the ends of the RSS motifs. Additional proteins, DNA-dependent protein kinase, Ku, Artemis, and a dimer of DNA ligase and XRCC4 are incorporated into a large complex with the RAG proteins. These RSS ends are joined, forming what is called the signal joint, to create a closed circle of DNA that plays no further role in the recombination process. The DNA hairpins at the ends of the gene segments are then cleaved. An additional enzyme, terminal deoxynucleotidal transferase, or TDT, is recruited and adds additional nucleotides to the ends of the DNA strands. The other enzymes in the complex ligate together the 2 ends of the gene segments, completing the recombination process.
Okay. Oops, wait, how do I can't. Wait, what just happened? Oh, there we go. Okay, so just going back to the point, this these non-functional genes into a functional genes, which is why I really like that video. And the importance of that is, as when you literally are breaking the DNA apart, and then this other enzyme or whatever it's called, TDT, what I think I mentioned it, it's adding back more new amino acids to it, and it's pretty much ligating it together. So as you can imagine, and this is called junctional diversity, but as you can imagine, there can be, which I will go into more detail later, but there can be so many different combinations, which ultimately lead to different proteins on the B cells and T cells, which ultimately can lead to different antigens or identifying different antigens, which is huge. So just to kind of reiterate, so what the V, D, and G segments, when they are recombined and close together, they are coding for specifically these regions right here that bind to the antigens on like a bacteria cell or a cell that's been infected by a virus. So here's what David Baltimore's experiment, like what he did. So he did an in vitro experiment. So he isolated DNA, and he pretty much used, he first measured to see if the length of the DNA got shorter. So if it was getting shorter, that means DNA was getting cut off, like it shown like the signal joint that I previously was talking about. This is a shorter strand than this strand because all this DNA is being cut off. So they use, it's called a tethered particle motion. And I tried to look up what it was, but it was really confusing. And they pretty much had 4 different groups. They had a control group with no RSSs. So there was no, they were seeing if RSSs had a had significance in it. Because if there was no RSSs, but the DNA got shorter, that means that there was some other gene segment that allowed RAG to bind. Also, they just tested to see if they tested to see if it was only had 12 RSS or if 23 RSSs had significance, and then they see if both was a requirement. And they also did it at different concentrations for RAG protein. So if they found out that if they added like a small amount of RAG and there was cleavage, or if there was a shortening of DNA, then they know that it was a different protein and not RAG. Or if they added a ton of RAG, like 50 nanometers, and there was still no cleavage, then they would know that it's not RAG. And they also use the equilibrium dissociation equilibrium constant, which I just thought it was interesting because we learned a lot about it in quantitative chemistry and in biochemistry, and I just saw it and I was like, oh god. But so the findings, they found a cofactor which is on the gene sequence that pretty much just helped the DNA shorten a lot, and it created, or it increased stability pretty much. They found that the groups with no RSSs and the one with only 12 RSSs, there was no DNA shortening. So that obviously means that, oh, and furthermore, they found that the one with both 12 RSSs and 23 RSSs did result in a shortening of DNA. So they knew that the 12 and 23 RSSs were significant, and it confirmed that they bound together. Also, they found out that the signal joints were approximately 12,000 base pairs long, or 800 base pairs long. They found that only 40% of the RAG RSS formation, complex formation, led to cleavage, which is actually significant because when you think about it, well, I'm actually going to go into more I'm going to refer to that in in the next slide actually. So I'll go back to that. But also it's important to know that this is in vitro and not in vivo. So like if you did this same experiment in a mouse cell, there's a lot of other different factors that that could affect the results, like histones that the protein, the DNA binds around, and the other different DNA binding proteins. Okay, I'm not doing that. So like, why is this so important to? Well, it first of all explains why we can we're able to identify so many different pathogens. Like if you think about it, and I don't know if anyone's taken like intro to microbiology, but you learn about all like how diverse and how many different microbes there are, and you wonder like a lot of them can be pathogenic, which means they can like cause like can make you sick, and you wonder like how does the body like identify this, like these small little microbes. Like I think it's just fascinating that this one mechanism can have like such a powerful ramification. Like when you look at it, they did a study, and theoretically they can have over a quintillion amount of combinations, which equals a quintillion amount of different antigens, which is amazing because I don't know. That just blows my mind that one little like change in DNA sequence, like what you just cut it and then you recombine it, can result in such a huge like impact. And also they figured out that this mechanism is a cause for Burkitt's lymphoma. And if you remember, I talked about how the RAG protein binded to RSSs on the DNA. Well, they found out there's a lot of different silent or cryptic RSSs found throughout the genome, and one's right beside. It's called the MYC proto-oncogene, which pretty much that gene promotes cellular growth. So you get like what happens is you get tumors, cancer. So I just think it's so like you think like how much of an impact this one study had on the world. Like it's just amazing, you know. And yeah, that's it. Which I guess it went faster than I thought. But does anyone have any questions or like, or is confused or, you know?
Hey, Erik, Zainab has a question and she's using my mic, so here she is.
Hey, Erik. First of all, you did really, really good, and I really liked your presentation. I wanted to ask what else you knew about the proto-oncogene while you were doing your research.
Oh, I'm not gonna lie, I don't know that much. The only reason why I added that part is because I learned about it in my immunology course, and I didn't do any more research on that part. I mean, I'm willing to. Maybe I
No,
can.
that's okay. That's so interesting, though. I'm gonna look into that.
In general?
Yeah.
Yeah, no, actually, I remember learning about it in a cell bio class I took, and also over the summer. And honestly, I feel like advanced bio classes, they always come up, but I always think it's really interesting that, like, just how it works. Like, that's literally a normal gene that just mutated. It causes all that uncontrolled growth. And I also think it's interesting that you need a mutation in both oncogenes in order for it to be expressed, I'm pretty sure. So even if one gene is mutated, if the gene from the other parent, if that's still a wild type normal gene, it'll compensate for that mutant gene and it'll still function properly. But when you have a mutation in both of them, that's when the proto-oncogene becomes cancerous and it leads to like that uncontrolled growth.
I did look it up just to see like who affected the most, and it said African men who had malaria or something with malaria, which I thought, I was like, that's crazy how like complex the body is and like how different things can interact with different things, you know? I don't know.
Yeah, no, it's super cool, especially with like proto-oncogenes, because it's like something in the environment that triggered that mutation to happen, right? Because like you're born with it. Like most of the time, people are born with those. Like we all have them, and usually in all of us, it's normally functional. But when someone develops cancer, it's because something in the environment triggered that proto-oncogene, like both copies of them to become mutant. So it's so interesting, like what could have triggered it and like how, like, because I know I took a cancer class. I'm sure those of you
Oh,
who
really?
come to SJC before, Dr. Parks, I highly recommend it. It's HON 296, and it talks about like the social history of cancer along with the biology of cancer. But we spent a lot of time talking about how there's so many different things that, like, you know, we grow up hearing like obviously cigarettes obviously cause cancer, but like red meat and just like all these other things that are linked to causing cancer. Like, I don't know, it's really interesting because literally I feel like at the I feel like anything can like trigger like that proto-oncogene to like fuck up, you know?
Yeah, and you know, to be honest, like I feel like when I'm learning about all this, like the mechanisms and stuff, I'm like, how are we like, how all of us aren't like messed up? You know, like I feel like there's so many ways that the body can easily mess up, but some, like obviously we learned a lot about like negative feedback and like these control in order to know like which ones like are bad and stuff like that. But I don't know. Or it's called negative selection, I mean, and positive selection. So, but anyways, I think it's just crazy, like how we're not all dead. I don't know. It's just
Eric, I definitely agree, especially with the pathway you showed us. It was super complex, and whenever we see pathways like that, whenever I learn about it in class, I always wonder, like research is so crazy. Like, how do they know like how do they come up with the techniques to map this stuff, right? Because when they do these experiments in labs, like how the hell do they know what to do to develop these experiments? Like, we literally have people whole ass generating plasmids, generating genes. Like, even when I was doing research, like before everything got moved online, I was a whole ass like cloning genes, like, and that's like the simplest thing you can do, like when you do molecular bio research. But it always blows my mind, like who is the first person to come up with these techniques and stuff like that? It's always crazy to me.
yeah. Like, do they just come out of like they just let me just think of it, like you know, like
Yeah,
what?
like how did they think? Or honestly, even going back to the freaking internet, how did they develop the internet? Like I can't even explain the internet. I'm sure like a lot of us probably couldn't. Like, it's so complex. Like, people who come up with these things or like research methods to study all of these diseases and stuff like that, or just like any technological like innovation, it's always crazy to me like how creative and smart they must have been to develop something like that.
Yeah, when I looked up what a tethered particle motion and it like what it was, and there like one video came up, and I was like, who figured this out? Like, and I didn't even understand what was happening, to be honest.
Yeah,
Uh,
or how you brought up like microbiome, if anyone's taken microbiome before. I'm in that class right now, and it always blows my mind when we did the microscopy unit. You can literally look at any cell through like transmission electron microscopy and scanning electron microscopy. It's literally like the microscope is shooting electrons like at these cells, and it helps like visualize it super, super, super well. Like, you get a really detailed image of it.
yeah.
But like, how the hell do you shoot an electron at something? Like, you know, like, it's so abstract, and I don't know, it's just so advanced. It always goes over my head.
Well, like if you think about this, well, first of all, this thing is on a microscopic cell. Like it's so tiny. And then when you think about like it's what this is literally on the DNA. Like how
Mhm.
did they figure that out? Like how did they get to that?
Yeah, and if you can you go back to the other slide you were just on?
Like this one?
Yeah, y'all see those antigen binding sites? Our cells do this when we get sick. Our B cells, like the B cells that we have stored in our spleen, whenever they encounter an antigen, those antigen binding sites that Eric has shown in like the bottom right picture, those automatically mutate, and they'll automatically like undergo, it's called clonal selection, to find that best fit at that antigen site so that it can like properly bind to whatever antigen or protein particle is on like the thing that is infecting you or causing your sickness. Like, how do our cells know how to do that? Like, isn't that crazy? Like, our B cells are doing that on their own. Like, I don't know, I think that's wild.
Yeah, and like when I'm like learning about like right now in biochemistry we just learned about like enzymes and all that, but we talked a lot about thermodynamics. Like I'm like how like I'm trying to think like how that applies to this too, and like if that's like pretty much the underlying cause of or foundation to like why these are like automatically doing it, or like you know what I'm saying. I don't know.
Yeah, no, I definitely get that. It's amazing.
Any more questions or comments, or is anyone confused? Because it took me a while to understand this, I'm not gonna lie. All right, so I'm done. I don't know how to stop. Oh wait, there we go.
Does anyone else have any questions? Okay, well, Eric, thank you. That was a really good presentation. It was definitely super interesting. And I think everyone who presented today did a really good job. We had some really, really interesting topics. So I think our next meeting, it should be the first week of September. Let me check that for us real quick. So our SJC meeting 3, it will be October 6th at 4 p.m. And yeah, I just encourage all of you guys to present. I think it's just really helpful to talk about it, talk through that research. And yeah, that's all I really have for you guys. Thank you guys for coming.
Bye, guys.